We see risks that many of our clients, including over-reliance on automation, lack of understanding, even though we can talk the talk around false signals, limited explainability and transparency. In the last week, I've had 3 or 4 inbound articles talking about the AI wall. And while I don't think we're there yet for threat detection, like it really is a cautionary tale for me for cutting humans out of the loop. So one of my clients described it really well to me. He said, it's a mix of choosing the right model, building the constructs to securely ingest and analyze the data, and then consistently tuning prompts and working on prompt engineering that yields the fruit. But with all these risks, I'm still skeptical. So I'll pose it back to the rest of you guys. What rewards have you actually generated rather than just hypothesized?
We've caught attacks. I mean, it can't get more serious than that. We've caught attacks that didn't match attributes we monitored, but that by actually going through the code and parsing it to an LLM and asking targeted questions, got caught. A lot of the security solutions out there are relying on the NVD to post a CVE publicly on the internet, and they've got a backlog of multiple thousand reports to review at all times. Many LLMs are capable of detecting attacks. So I think at this point, AI skepticism in security really comes down to the subject. If we're talking about open source dependency management and actually parsing through code and understanding what it does, it has proven its impact already since GPT-3. So we're already far beyond the point that we can be skeptical about that. I think the biggest downside to come to the flip side of the positives is that, well, guess who is faster at adopting LLMs than security companies? Bad actors. And they've got access to all the same technologies that we do because LLMs were not built by the security ecosystem. It was built by other technology companies out there that made it publicly accessible to the greater good. Therefore, great use cases have emerged, but also bad actors have started using it. So I think that the biggest downside of AI is the fact that bad folks also get to use it, and that there's a lot of solutions out there by good people that are not keeping up to date and are not using it to detect AI. I think the only way you can fight an LLM-based style attack nowadays is by very rigorously making sure you're using the most modern LLM yourself and have implemented it in the most capable way possible.
If you're using the newest one every time, how concerned are you guys about data poisoning?
We use publicly accessible data. There's really no downside or risk to what we do with the data. So in our use case, coming back to, we can be negative about AI in a general sense, but I think there's many use cases where it's already been proven to be very effective. So there may be specific cases where your very sensitive data may be at risk. Well, sure, handle it with extra care, right? But for certain use cases, like open source dependency management, that's all public records. That's all data that's out there, right? So there's no data risk involved with that.
On the data risk side, just quickly, and it gets to something you were saying, Simon, why haven't the legacy traditional vendors adopted it more? I think we have an industry structure issue where we've got folks vying for, being platform solutions, locking customers in with their data and proprietary query languages, et cetera. So the big platform companies may not be incented to innovate quickly. We're seeing some early success. I wouldn't claim that we've proven the hypothesis completely, but running our intelligence on Snowflake as a native app. What does that mean? It means we don't get your data. We bring the intelligence to your data, and it runs there. And so to the extent that you're comfortable with Snowflake having that logging data, not everyone is, but some folks for sure are, you now don't have to create a pinhole or bigger to get data out to us, munge it, get it back to you. So it's a great question. There are some approaches where you can handle the data gravity and the loss of data risks. I would just quickly say, and I'll throw it over to the team, where there are patterns out there to help you, like differential privacy, et cetera, to help you basically try to make models immune to inversion attacks, but inversion attacks are possible. So at least our kinds of clients are likely being attacked by state actors. So we have to really think seriously about that as well. So a model, as obscure as it is, if you're not careful, it is possible that someone with enough compute and patience could use it to get back to the underlying data. So that is something that we should all take seriously. The last thing any of us want to be, of course, is an attack vector.
I do think there is something to your point though, Michael, about data poisoning. I mentioned wanting to be a hacker and not being good enough myself. I am lucky enough to work with a number of security researchers. When you talk to them, they're poisoning data sets online all the time. Like they know people, they're doing it, they've done it in their past lives or whatever, but people, anything from just now with LLMs, obviously textual data, but previously, virus total data and so on could be, it's public, which means that anyone can influence it, right? And so there are real risks there. And then the second point I would make is that, on the LLM side, I think LLMs are an aspect to how AI, these are obviously current models, current techniques that are most prevalent, but there's existing, predictive AI models that are really useful on the detection side. The LLM piece really is useful in the investigative and response side, right? Contextualizing, dealing with unstructured data, being able to, anthropomorphizing, but reason in a sense like humans, even though that's not really what they're doing. But ultimately, with LLMs, the reason many LLMs are seemingly really impressive and have these great capabilities, but we've failed to see them being productionized or ending up in widely accessible solutions, is that they aren't robust enough that you just trust an LLM in a zero-shot prompt manner, right? You don't just say to the LLM, hey, is this malicious or is this benign? You really have to structure how you're using the LLM in order to be able to get meaningful and correct sort of answers out of it. And absent that, it's going to create more work than actually solving things for you.
By the way, in our domain, which is a bit an angle of cyber, it's just an angle of cyber, there's one more aspect to it. Because until now, fraudsters have tried to produce something that fools you, the picture of the ID, the face, or whatever. Now we are seeing another attack vector, which makes it all difficult, which is trying to control the value chain or the process itself, which means that what you get on your side may not be the same thing that your potential client, a customer, has just been taking a picture of. In other words, injections, hijacking, etc. So it's kind of a factor that's added in terms of we have to look at the process or the flow of all the inputs we are getting, not just the inputs themselves.